Behind the tree, top, second from the top. That one. Yep. All right. I was really to commit to the bit. I'd have brought iced coffee, but I'm not. All right. I put this lid on my stamp yesterday. I haven't eaten it except juice still. All right. Let's go through this. You can do this either way. I'm probably actually going to do both ways just so we continue practicing things. So if we are to solve this one by graphing, we're going to have our y-intercept at 4 and our slope at -2, so down to right 1. And it's going to look like this. So that is an option. Getting my second line. My x-intercept is going to be +9. My y-intercept is -3. Like that. That is an okay way to do this. We can find our point of intersection that way. Just because I provide you a graph doesn't mean you have to solve with graphing. We can always come in here and notice that y equals this piece and substitute that in place of the y to solve this algebraically to get -x plus 3 times -2x plus 4 equals -9. And solve it with substitution like we did yesterday. To get -x minus 6x plus 12 equals -9. So -7x plus 12 equals -9. -7x equals -21. Yeah, because therefore x equals 3. Which my x value of my intersection is, in fact, 3. Plug it back into the y equals -2 times 3 is -6 plus 4 gives me -2. So using substitution or solving by graphing gives us that same intersection point, 3, -2. It's the same thing, just two different ways of doing it. Substituting it in or graphing and finding where they cross. And in fact, I'm going to show you yet another way to do it today. So questions on this before we go into a different direction of how to do it? So I think some of us noticed yesterday on the homework that some of the equations that I gave you, especially on the bottom half, were really, really gross for doing substitution. They were getting all fractiony or decimally and gross. So we're going to have a process called elimination. Give me this stuff here. I should lay up here. I get to my couches. This way. No, that feels so bad. Oh my god. I use my couches. Just lay down. All right, so I've got two equations here, and what we are looking for when we are solving with elimination is to have one variable that has the same coefficient, so the same number, with the opposite sign. Yep. I want to have one variable, and I will even write it down. I'm going to write it over the side over here. Ooh. We want one variable to have the same coefficient, meaning the number in front, with the opposite sign. So 2 and -2, 1 and -1, 3 and -3. Doesn't matter what it is. Same number, opposite sign. Because what we're going to do is we're going to old school add things together to make one of the variables eliminate. That's why it's called elimination. I don't know how y'all do that without yelling all day. Oh my gosh. I'm doing that with headphones in. Did this say sign, not sigh? I'm just bad at writing. So if we look at these equations over here, my coefficient on all of these variables, there's an invisible 1 in front of them. So I've got 1x plus 1y equals 7. 1x minus 1y equals 5. I have in my y's, the same number with the opposite sign. That's what we're looking for to be able to start elimination. Same number, opposite sign. I'm going to take those blobs away because it's about to get really arrowy in here. And what we're going to do is we're going to come through and we are going to add these two lines together in columns. Old school 3rd grade column addition steps. Adding in columns. 1x plus 1x. First column. Gives me 2 x's. Second column. 1y minus 1y. Gives me 0 y's. That's the goal. On this step, somebody should cancel out. And then we have 7 plus 5, which is 12. So we add them together in columns. And the whole goal, the point of this, is to have one of them have a 0. If you do not wind up with a 0 there, stop and don't keep going because you did it wrong. The whole point is having that 0 there, so this chunk is going to straight up disappear, and we're going to get that 2x actually equals 12. So what does x equal? 6. Systems of equations, again, means we're coming up here and we are going to have an x, y point. So since I have x equals 6, I need to figure out what y is. We take any of our equations and we substitute it in. So my x is 6. So I can take that first one, 6 plus y equals 7. What does y equal? Y equals 1. So our solution is the point 6, comma 1. This is really handy when we have things that have, like, that are in standard form, that have numbers in front of all the variables. That way we don't get so many fractions, especially during substitution. Because in substitution, on some of these, it'd be very fractiony. Doable, but fractiony. And we're not a huge fan of fractiony things. Okay, so that's the process with solving with elimination, is we make one variable have the same coefficient, opposite sign, old school, add them together in columns, solve for the other variable. We're going to try that a few times today. So things like this are why we have elimination. So I have negative 2x minus 9y equals negative 25. And minus 4x minus 9y equals negative 23. So it's really close to being set up perfect. Like, it's real close to being perfect for elimination. My y's, again, have the same number, but they don't have the opposite sign. Oh, hello. What's going on there, screen? Stop being a jerk. So what we're going to do is I'm actually going to multiply one of the equations on both sides by something in order to make them be what I want them to be. So I'm going to take my top equation and multiply the whole thing on both sides by negative 1. That is going to make me have the same number, opposite signs on my equations. So I'm just going to rewrite both of them. So we're going to have 2x plus 9y equals positive 25. And then our second equation, I'm going to leave exactly as it was. 4x minus 9y equals negative 23. We want the same number, opposite sign. So I can come down here and add them together and have somebody cancel out. That's the whole goal. Elimination, the goal is for something to cancel out. So we're going to add in columns 2x plus negative 4x. Gives us minus 2x. 9y plus negative 9y gives us 0y. And 25 plus negative 23 gives us 2. The whole point is so that this piece cancels out. One of my letters should cancel out. If it doesn't cancel out, stop and go back. Can you get a sense of where people mess up? We have minus 2x equals 2. What does x equal? Negative 1. That's not our solution. It's only half of it. So we've got to take one of our equations, and I can take anything above the equal sign. So anything from above the addition, and I can plug it into one of those. It genuinely does not matter which one. So I'm going to grab the bottom one because I don't know why. I feel like it. So we're going to take minus 4 times our x of minus 1 minus 9. Why did I change colors? There we go. Minus 9y equals negative 23. So we're going to multiply that. Negative 4 times negative 1 gives me positive 4 minus 9y equals negative 23. Then what do we do? Minus 4 on both sides. That 4 itself is positive, so we minus 4. And we get negative 9y equals negative 27. So what does y equal?
3.
Y equals 3. Because here we're dividing both sides by negative 9. So our solution is the point negative 1, comma 3. So it feels like a lot more writing today, but it gives us significantly fewer fractions. Imagine trying to do this system with an x equals or a y equals. Ooh. Getting to an x equals, we're going to have to divide things by 2 or by 4. And none of the other numbers are even. So none of them are going to divide pretty. We have fractions everywhere. Even if we got a y equals, we'd have fractions everywhere. Because none of those things divides by 9. So doing elimination saves us from fractiony horribleness. We're going to do another one. Now I've got 2x plus 5y equals 1, and 3x minus 4y equals negative 10. And I don't see anybody nice that looks like they're going to get along. So 2x plus 5y equals 1. 3x minus 4y equals negative 10. So just like on the last one, how I multiplied by negative 1, I can multiply again. I can multiply both equations if I want to. Because I need to make one of my variables have the same number with the opposite sign. And it genuinely does not matter which one. I'm going to do x's this time because last time we made our y's cancel out. Last 2 times. So what we're going to do is we're going to look at my x's. And we're going to say, all right, what is the least common multiple that they have in common? What do 2 and 3 have in common that I could multiply them to?
12.
You could do 12. We could also do 6. What would I need to multiply 2x by to make it be 6? By 3. So I'm going to take this whole equation times 3. What would I need to multiply 3x by to make it be 6? By 2. I need one of those to be negative. So I'm going to do this one times negative 2. Because I need them to have the same number, opposite sign. So we're going to wind up with something that's like 6x plus 15y equals 3, and negative 6x plus 8y equals 20. They still mean the same thing. As long as I multiply all the pieces, we're good. I can multiply them by whatever I want. And then we're going to come through with my green and purple equations over here and add them together just like we did. 6 in columns now. 6x plus negative 6x gives me 0 x's. 15y plus 8y gives me 23y. And 3 plus 20 gives me 23. The whole point of this is so that one of my variables eliminates out. That's why this is called elimination. If one of your variables does not eliminate out, stop and go back. We're sensing a theme on where people make mistakes. Because we should have wound up with just a single variable left. 23y equals 23. What does y equal? 1. But we're not done. We got to figure out what x is. And now I have a gazillion choices on which equation to do, because I can pick any equation before this equal sign. I can pick my 2x plus 5y equals 1. I can pick 3x minus 4y equals negative 10. I could pick 6x plus 15y equals 3. I could pick negative 6x plus 8y equals 20. I can pick any of them before the equal sign. Anything before the equal sign. I'm going to go ahead and take the top one because I like pluses with absolutely no negative signs best. So I'm going to take this very, very top one, and I'm going to substitute it in there. So we're going to take our 2x plus 5 times our y of 1 equals 1. Oh, my pen's being a jerk. So 2x plus 5 equals 1. What do we do to get x by itself? Subtract 5. 2x equals negative 4. How do we get x by itself? Divide by 2. And we get that x is what? Negative 2. Have confidence, you're right. So our solution is negative 2, comma 1. It takes some practice to get through it. But once we get the hang of it, it's not the worst. We are going to be using elimination throughout most of the year. Honestly, we'll be using substitution more, but we're going to continue to use this throughout systems and through all kinds of crazy things throughout the year. So we're going to be using elimination a lot. So questions on this one. We'll have one more like this, and then we'll do a story problem. You know, everybody's favoritists. Okay, one more normal one. 18x plus 21y equals 12, and 6x plus 7y equals 4. And again, you don't have any that are set up perfectly. So we're going to have to multiply something. So write them down. 18x plus 21y equals 12. 6x plus 7y equals 4. And then we're going to pick which variable we want to eliminate. Do you guys want to eliminate x's or do you want to eliminate y's?
Y.
Y. Let's do y. It genuinely does not matter. You can pick either one. So for the y's,
No solution.
what do I need to multiply by to get them to the same number?
3.
3. And I need them to have the opposite sign, so we're going to multiply by negative 3. So I'm going to take this whole equation and multiply by negative 3. The top one's not changing, so we're going to have our 18x plus 21y equals 12. Oh, my pop socket fell off again. Ooh. And then our bottom one becomes negative 18x minus 21y equals negative 12. So 18x plus negative 18x gives us 0 x's. 21y plus negative 21y gives us 0 y. And 12 plus negative 12 gives us 0. Both of my variables canceled out here. So what's left on the left side? Just a plus. Oh, I don't just put a plus. So if there's nothing left, what are we going to put? 0. Got you. It was just like a 1/4 inch too far for you to reach. So we've got 0 equals 0. Does 0 equal 0? Yeah, that works. So what's our solution here? It's not 0. Because 0, if we had like x equals 0, we'd have to plug it back in. Does this work all the time, forever and ever? Does 0 always equal 0? If x is 300, does 0 equal 0? Yeah. If y is negative 5,000, is 0 equal 0? Yeah. So no matter what x is, no matter what y is, 0 equals 0. Which means there's an infinite number of solutions. Infinitely many. If both of your variables cancel out and your other side is 0, is when we have infinitely many solutions. With linear or with elimination, we will either get 0 equals 0 or 0 equals a number for no solution. 0 equals 4 would be a no solution situation, meaning we have parallel lines. This is the same line twice. It's the same line written in 2 different ways. Because if you look at our equations closely, it's literally the same equation, just multiplied by 3. Okay? So we can still get our infinitely many solutions. We could still get no solution. Questions on this one? We have one more bit. And it's a story problem. We've got Becca and Jasmine A are selling candy bars for a fundraiser at school. Becca sold 3 caramel bars and 5 peanut butter bars for $13, and Jasmine A sold 8 caramel bars and 2 peanut butter bars for $12. How much did each bar cost? So what is it we don't know? How much did each bar cost? So we need to know the cost of the caramel bar. And we need to know the cost of the peanut butter bar. So that means we need 2 variables. What do you want our variables to be? We can do x and y. We can do c and p. X and y. So I'm going to make caramel x. Whenever you have to pick your variables, tell me what they are, please. X is caramel, y is peanut butter. Not only is it helpful for me who cannot read your mind, it's helpful for you when you go, oh shoot, which one was peanut butter again? And what we're going to do next is we're going to write an equation for each of these girls. Becca sold 3 caramel bars and 5 peanut butter bars for $13. So Becca's going to get an equation. How can I write Becca's fundraiser as an equation? She sold 3 caramel bars. So 3 times however much the caramel bars cost. And she sold 5 peanut butter bars for a total of $13. How about for Jasmine A? Can you guys see how to write Jasmine A's? Jasmine A sold 8 caramel bars and 2 peanut butter bars for $12. How can I write an equation for her? 8x plus, 2y equals 12. So when we have 2 people, that's a big old clue on how to split up your 2 equations. Or if we have 2 companies, there's your 2 equations. Then what we're going to do is we're going to solve it, just like we did before. I've got a system of 2 equations here. 3x plus 5y equals 13. 8x plus 2y equals 12. Do you guys want to eliminate x's or y's? Y's. It doesn't matter. You can do x's. It's not wrong. So what are we going to need to multiply this top equation by? Yeah, we can do 2 or you can do -2. I'm going to go ahead and grab -2 because I heard the negative come out first. What are we going to multiply the bottom one by to make them have the same number, opposite sign? +5. So that's going to give us -6x minus 10y equals -26. And we're going to have times 5, 40x plus 10y equals 60. And you can use a calculator. Hopefully we're okay with that one. That green pen just loves to run away from you because it's that green one again. So I have mine all contained in a cup. And I have one at home too with my pens at home in a cup. All right, so we're gonna add them together in our columns. -6x plus 40x gives us 34x. -10y plus 10y gives us 0y's. And 60 minus 26 gives us 34. The whole point of this is for one of our variables to cancel out. If we don't have a variable cancel out, stop. We should get 34x equals 34. So what does x equal? 1. But we're not done. We need the cost of each bar. So I need to go figure out what the peanut butter bars cost now. I can use the pink equation, I can use the blue equation, or I can use either one of these black equations above the equal sign. It genuinely does not matter. I'm going to go ahead and use the blue one because I like to change it up and not always use the top one because otherwise y'all get stuck in a groove. So we're going to take our blue equation and we're substituting in the fact, now I know that the x is really a 1 plus 2y equals 12. 8 times 1 gives me 8 plus 2y equals 12. What do we do to get y by itself? Subtract the 8 on both sides. So you're going to have 2y equals 4. Gives me minus 8. Then we divide by 2. And we get that y equals what? 2. So we have x equals 1 and y equals 2. So how much does a caramel bar cost? $1. How much does a peanut butter bar cost? $2. Also, the only fundraiser I will participate in. Y'all ever have a club that does the box of candy bars? Okay, you're gonna give me a candy bar right then. No ordering involved. Heck yes, I will participate in that one. That's the only one. Only one. You bring me a pamphlet, not happening. You bring me candy bars, I'm in. In. Okay? Just being real clear. I don't even order for my own kids' pamphlets. Okay, so the homework today is the exact same as yesterday. I'm not handing you a new one. I know, shocker, I've given you so many. So it is the same worksheet as yesterday. You guys can finish it out. It is homework 2-5. You don't need to do both. I just keep putting the page numbers up here because I have a couple of people that prefer to do it on loose leaf paper. But do not do both. Our chapter test is the 22nd, which is just over a week away. It's a week from Friday, I think. Yeah. Okay. So work on this stuff. You guys have about 10 minutes until announcements. 10 minutes to the end of the period. You've got about 8 minutes until announcements. These two. Yes.